in your chemistry book, in Chapter 4, Section 2, Classification of Chemical Reactions. And we're going to talk about 4 different classifications that you need to know. We'll go down here to the table here, and here they are. And let me zoom in here. There we go. So it says the combination reaction is A plus B equal AB. And number of reactants, you have 2 or more reactants that are reacting and coming together to form 1. The number of products is going to be 1 product from these reactants. And that's called a combination. Basically, you're combining 2 different reactants here into 1. So that's the first type. That's probably one of the most common types. And then we have the opposite, and it's decomposition. And so you're going to have 1 reactant forming 2 or more products. This reactant is decomposing into more products. And here's an example of that. 1 product decomposing into 1, 2, 3 different products. So 1 reactant and 2 or more products. So these are pretty easy to see when you have that. Onto single displacement is when you have basically you're going to have these next 2 are going to be 2 reactants and 2 products. So you have 2 reactants and 2 products here, but one is going to be an element. It's going to be a single element, and the other is going to be a compound. And you're going to see one is reacting with the other to produce a precipitate. So basically, you have these 2 reacting and forming, as you can see, 2 different ones. So, and then you have a double displacement. I call these are ions. Usually ions react in these. And this double displacement is like I call it doing the do-si-do, is that AB and CD and AD and CB, you see they change partners. So that's the double displacement. So these are the ones you need to know and recognize. So when they give you one, you can right away figure out, oh, that's the double displacement, or that's the single displacement, or that's decomposition or the combination. So this is how you can identify these reactions of chemical reactions. Now I'll show you some more about it in just a little bit in my notes here, but let's go on to this next here. So here's a picture here, as you see in the corner here, is decomposition. Basically, you have precipitate. When I say basically something is coming out, the precipitating out during the reaction, and this is decomposing. This is the decomposition of HGO, so mercury. So on to. Well, let's go to my notes before I get into the leavening agents and stuff. And I want to go over the notes so you could get this more, and there's some examples of it. So let me move here. So here we go, we're focusing in. So going over these chemical reactions. So here we have the combination. So this is just quick to show. So you're going to go over these, and then you're going to have these on the test too. So you need to find out which one this is. Well, the first type of chemical reaction is the combination. That's A plus B equal AB. There's 2 substances that are chemically combining to form 1 new substance, right? So an example would be that carbon reacts with oxygen here. Here's carbon, and here's oxygen, a carbon solid with an oxygen gas, what the S and the G mean here. So it's reacting with, carbon's reacting with oxygen to make carbon dioxide here, which is a gas, right? Another example would be a sodium metal with chlorine from salt. So you have a sodium metal here, and with the chlorine, these 2 reacting, and they're forming salt. See where 2 react to form a new compound, 2 elements forming a compound, or two forming 1. This one here, you have calcium oxide with water to form calcium hydroxide. So these two are 2 compounds, But these two compounds are combining together to form a new compound here. So you have this calcium oxide with water, and it's forming calcium hydroxide here. So just basically two of them are forming one together, making a new one. So let's go to the next here. Let's see if we can zoom in on this one here. Okay. So here we have a decomposition reaction. That's the reverse. So you have a breakdown of something. So you have a breakdown of a compound into two or more simpler substances. A lot of times I put a little delta there. That means heat. A lot of times you need heat. You usually need heat or electricity to break down and decompose things, right? So the decomposition by the electric current is called electrolysis, or basically having an electric current there means that electrolysis was provided, right? So here we have example. Here is bauxite, and it's going to form aluminum oxide. So here you have bauxite. It looks like AlO3. That has electric current through it. And then it forms 4Al plus oxygen. So it's breaking up there into aluminum and oxygen here. So this is decomposing. When it breaks up, it decomposes. So here's another one. Sodium metal decomposes to molten sodium chloride. So here you have the sodium metal here, and they're passing electric current through it. So it's decomposing into sodium plus chlorine. So chloride, or chlorine, I should say. Another is, if I could keep this from, there we go, it's the lowest I can go there. So calcium carbonate, and it's decomposing into calcium oxide and calcium dioxide. So here you have calcium chloride, just one over here, and you're heating it up with this delta, and it's forming two new substances. So let's see. The next here, we have an example of sodium carbonate decomposing into sodium oxide and carbon dioxide. So here it is decomposing again. Here we have the little delta, they're adding heat, and it decomposes into sodium oxide right here and carbon dioxide. Another is the metal oxide of mercury. And so we have mercury oxide here, two mercury oxides, and we're heating this up to high temperatures, and then we're going to decompose it into mercury and oxygen. So that's so we went over the composition, or combining, I should say, the combination synthesis they call it, and onto the decomposition. So now let's go to the other two. Put this in here so you can see it. Alrighty, then here we go. So we have, this is called, we're going to talk about two others, single displacement and double displacement. Single displacement is going to be one that's kind of harder to see. But what it is, basically, you're going to replace one element in the compound with another. So you're going to replace. It's displace means replace, kind of. So it's a displacement of a hydrogen from water or acid, usually going through. This is a type of displacement. So here it is. Here's your equation. A plus BC equals B plus AC. So you're going to displace one. Like one's going to be displaced from the other. The B and the C are going to come apart, and then the C is going to go on to the other side. So it's called displacement. They're changing partners, but there's one lone partner and one compound partner, right? You got it? So the example here would be sodium reacts violently with water to displace hydrogen. Now, whenever you have this whole picture of this, as I'm doing the arrow, and it does a do-si-do arrow, kind of like, well, not that, I would say it's like a wave, goes like a wave. Those are all displacement. Like this one, we have we have water. We basically have sodium and water. And so basically the N is going to combine over here. The N is combining with the oxygen over here to be NOH, but it's displacing the hydrogen. So the hydrogen is going to come out and the hydrogen is going to be alone here. See how that goes? To look at it easier, you can put down, instead of H2O, we put HOH. That's H2O. So basically, the sodium is going to come over here. It's going to grab one of these hydrogens, and the hydrogen is going to come loose, and then the rest of it's going to be left. See how that displaced? The hydrogen comes loose. The next one, we have the zinc. So the zinc is going to come and displace the hydrogen here. The hydrogen is going to come loose, and hydrogen comes loose, and then it makes zinc Cl. And with the basically, I put the 2 pluses there. That's why we have the Cl2, because you need 2 of these with 2 of these when in the equation. You know that already. So basically, the zinc is displacing the hydrogen here. So on to the next one there. The same thing is copper and silver nitrate. So we have the copper coming over here, and it's displacing the silver. So 2 of the silvers come loose, and then the copper combines with the silver with the nitrate. So we have copper nitrate, and the silver is loose. See how it displaced the silver. So we have another example here. Go lower. We have an example of chlorine displacing liquid bromine. And so we have the chlorine coming through here, bumping into the bromine coming loose over here, and then the sodium chloride is left. See how it bumps one out? That's called displacement. So I hope you got that all. You know, I don't know if I looked at the copper here and the copper with the displacement of the silver. I didn't know if you could see it if it was focusing in on there, but there we go. So the last one we have is double displacement. Okay, the double displacement. So double displacement, I call the double displacement the do-si-do, which, like when you're playing square dances, you know how you change partners. So the ions, you'll have positive and negative parts and ions in all of these different compounds, you know, and they're basically holding each other together by electrons. Well, all of a sudden, the cations decide to exchange with the anions here. So the cations exchange with the anions. So you have like AB plus CD, now AD plus CB. They change positions. So it's basically double changing positions. So doubles are changing. So they're interchanging or changing partners, is what I said. So here's an example of it. You have sodium sulfate and you have barium chloride, and then they change partners to become sodium chloride and barium sulfate. See how they just change their partners? So basically they're going to change their partners around, and they become with different partners. So here's another one. This is called double displacement. Here's lead nitrate, and we have potassium. Remember, K is potassium, chromate here. And they're going to change partners here and have lead chromate and potassium nitrate, you know, so they change partners. That's how you do the double reactions, the double displacements. So I hope you get that. So now, because we're going to do some problems here and see if you can have these problems in your book too. Let's go ahead and go through them here. Some of these, this is going to be exercises 4-1. Let's go to the top here. See what we're on time-wise. Okay, we're okay. So we're going to classify. They give you this equation. They say classify. What is this? Is this going to be a single displacement, a double displacement, or is it going to be a decomposition, or is it just going to be a simple combination? So let's look at this. When we looked at this, well, it looks like we have an element, and aluminum's an element, we have a compound. And then we have an element and we have a compound. So that looking at this, it's not a double displacement, but it's going to be a displacement because the aluminum is going to come over and it's going to displace the iron, and the iron's going to shoot out here. And so the iron is going to be on its own now, and it's going to combine with oxygen. Basically, the aluminum is going to bump this one, and the iron is going to bump off, which it did, and then aluminum's going to combine with it. It's just bumping a guy off, right? So this is the iron is displaced by aluminum, so it's a single displacement. B here, it's another one. So we have magnesium, it should be capital there, magnesium solid with sodium. And basically these two are what? They're combining to become magnesium magnesium sodium, or compound. So magnesium sodium, I guess. So onto this. This is a synthesis. This is just a regular reaction called combination reaction. So this is a combination reaction, the simplest type. Okay, we'll go up here. Next one, C here. We have basically a compound here, hydrogen chloride right here, and we have another compound here, which is potassium acid, basically potassium hydroxide, and on here to water, H2O, and potassium chlorate. So if you look at this whole thing, they're basically what? You have a compound, you have another compound, you have another compound, you have another compound. What's happening in all these compounds? Well, it looks to me they're just changing partners. So, but you have double partners there, so you're going to have a double displacement. They're changing partners. Okay, D here, we have a silver oxide, and then they're putting it under heat, and then the silver comes out and the oxygen comes out. What do you call that? Well, they're basically, these are decomposing, right? Let me pull this up so you can see it better. There we go. So it's going to be decomposition reaction. AB going down to A plus B. So it's just basically this one compound is decomposing into its parts, which is silver and oxygen. Okay, the last one down here at the bottom is going to be ferrous oxide and hydrogen, and then it's going to go into hydrogen oxide and onto iron, which is ferrous iron. So what happened here? Basically, this one's coming with the hydrogen. Basically, the hydrogen's bumping into this one. Hydrogen's bumping into it, and well, wait, not the hydrogen's bumping. The iron's bumping into it, bumping off the iron, or the hydrogen's bumping it off the iron, and then the iron's set free. So this is just going to be a regular displacement. And it's A plus BC equal B plus AC. The reason we know this is because hydrogen is an element. This is a compound, this is an element. This is a compound, this is an element. So you know that there's only one of them being displaced. It's bumping one off, which it's doing in that one. Okay.